So Chapter 10, the language of hypothesis testing, is where the rest of the semester we're going to be working with how do we test these claims that people make. We don't know what those are going to look like yet, but we're going to get into the basics of it in this first lesson. So our first object of is we're going to look at our objectives. First of all, determine the null and alternative hypotheses from a claim. That's the important part. We'll look at type 1 and type 2 errors later on, and we'll state conclusions. And I have a little cheat sheet to help you with stating the conclusions. So that's a good thing. So we the first one. The environment of our problem is that we want to test whether a particular claim is believable or not. This is what we call hypothesis testing. It's one of the most common things we want to learn how to do in statistics. That's why it's one of our goals. So a hypothesis test involves two steps. Step 1, state what we think is true. And step 2, quantify how confident we are in our claim. Sounds kind of like a confidence interval to me, and it is sorta. The first step is relatively easy. The second is why the heck we need statistics. We are usually told what the claim is, that is, what the goal of the test is. Now, similar to estimation in the previous chapter, we will again use the material in Chapter 8. Remember our gas mileage problem? We want to quantify that. An example of what we want to quantify, here we go. A car manufacturer claims that a certain model of car achieves 29 miles per gallon. We test some numbers of cars. We calculate the sample mean. It turned out to be 27. Is 27 miles per gallon consistent with the manufacturer's claim? How confident are we that the manufacturer has significantly overstated the miles per gallon achievable? Remember I told you my story. How confident we are in that the gas economy is definitely less than 29 miles per gallon. We would like to make a statement like, we're pretty sure the mileage is less than 29, or it's believable that the mileage is equal to 29. A hypothesis test for an unknown parameter is a test of a specific claim. So we compare this to a confidence interval which begins an interval of numbers, not a believe it or don't believe it answer. It gives us an interval of numbers, not a believe this or don't answer. We're looking for the believe this or don't. The level of significance represents the confidence we have in our conclusion. Okay, remember we talked about alpha. Alpha is our level of significance. How do we state our claim? Well, our claim is the statement to be tested. It's called the null hypothesis, and it's written H sub 0 is how I say it, not H sub naught is how others say it, or H sub 0 or H naught. How do we state our counterclaim? Remember in geometry when we had examples, then we had counterexamples. Counterexamples were the opposite of what we were claiming. Well, our counterexample is the opposite of the statement to be tested. It's called the alternative hypothesis, or H sub 1. There are different types of null hypotheses, alternative hypotheses pairs, depending on the claim and the counterclaim. Let's see how this works. One type of H sub O, H sub 1 pair is called a two-tailed test. It tests whether a parameter is either equal to something versus not equal to something. Notice H sub O is equal, H sub 1 is not equal. Hint, H sub O will always have equal in it. H sub O will always have equal in it. An example of a two-tailed test. A bolt manufacturer claims the diameter of a bolt average 10 millimeters. So H sub O equals 10, and H sub 1, the diameter is not equal to 10. Let me do that again. The bolt manufacturer claims the diameter of a bolt is 10 millimeters. So H sub O is equal to 10 millimeters, and H sub 1 is it's not. An alternative hypothesis of not equal to is appropriate since the sample diameter is too high is a problem, and so is if it's too low. Think about it for a second. If I have too big of a bolt, I don't think it's going to fit, and if it's too small, it'll wobble around and break anyway. Thus, we have a two-tailed test. Another is called a left-tailed test. Test whether the parameter is equal to versus less than some value. Now, some books will use greater than or equal to in the H sub O. Again, it still has the equal in it, so that's okay. So H sub O, our parameter is equal to some value. H sub 1 is less than. Notice left-tailed and less than both start with L. And if you look at the arrow in the less than, it points to the left, so it's a left-tailed test. An example of a left-tailed, a car manufacturer claims the miles per gallon of a certain model car is at least 29. Well, if it's at least 29, it's equal to or more than 29, and so H sub 1 would be less than 29. An alternative hypothesis of less than 29 is appropriate since the miles per gallon too low is a problem, but if I get more, or too high, that's not a problem at all as far as I'm concerned. Thus, it's a left-tailed test. Another type, the third one, is called a right-tailed test. Test whether the parameter is equal to versus greater than some value. So again, I would use less than or equal to in some textbooks. This one happens to use only the equal. So H sub O is equal to some value and H sub 1 is greater than some value. Here's an example. A bolt manufacturer claims that the defective rate of their product is at most 1 part in 1,000. So the defective rate is 0.001, or less than 0.001 would be even better. And H sub 1 is greater than 0.001. If we're greater than 0.001, that's a problem. An alternative hypothesis of greater than 0.001 is appropriate, since if it's less than that, that's good. But if it's greater than that, that is a problem. Thus, we have a right-tailed test. Comparisons of these three types of tests. The null hypothesis, we believe that this is true. So here we go. In a two-tailed test, a sample value that's too low is a problem, but so is a value that's too high. The left-tailed test, being too low, is a problem, but more than that is not. A right-tailed test, if we're too low, it's a problem. If we're above that, it's not a problem. That kind of makes sense. Manufacturer claims there are at least 2 scoops of cranberries in each box of cereal. What would be a problem? Well, if it has too many cranberries, that's not a problem. But if it has too few cranberries, that's a problem. So what type of test? We have a left-tailed test. The bad case is when there are too few. A left-tailed test. Manufacturer claims there are exactly 500 milligrams of medicine in each tablet. So what would be the problem? Well, if you test the amount of medicine in each one and the sample is too low, you're not getting enough medicine. Or if it's too high, you're getting too much medicine. Both are bad cases, so this is a two-tailed test. A two-tailed test. A manufacturer claims there are at most 8 grams of fat per serving. So what would be a problem? Parameter tested is the number of grams in fat. So if the sample is too low, that's okay. But if the sample is too high, now you've gone overboard. You've got too much fat, and that is a problem. This is a right-tailed test. It's going to be a problem to the right. Okay, there are 2 possible results of a hypothesis test. You can, if we believe the null hypothesis could be true, this is called not rejecting the null hypothesis. Note, this is only saying we believe and could be. We're not really stating that it's true. If we are pretty sure the null hypothesis is not true, so the alternative hypothesis is true, we call that rejecting the null hypothesis. So in this case, we're pretty sure we're right. Okay, so that is the end of the slides for today. We'll pick up there on the next lesson. Okay, so now we have type 1 and type 2 errors. In comparing our conclusions, not reject or reject, with reality, we could either be right or we could be wrong. When we reject and state that the null hypothesis is false, but the null hypothesis is actually true, or when we do not reject and state that the null hypothesis could be true, but the null hypothesis is actually false, these would both be undesirable errors. Here's what it looks like. The summary of the errors. If H sub O is true and we do not reject, we have the right conclusion. If H sub 1 is true, but we do not reject, we've created a type 2 error. If H sub O is true and we reject, we have a type 1 error. And if H sub 1 is true and we reject, we have the correct conclusion. We can see there are 4 possibilities, 2 of which we are correct and 2 of which we aren't. So basically we have a 50-50 chance of getting it right. When we reject and state the null hypothesis is false, but the null hypothesis is actually true, it's called a type 1 error. When we do not reject and state the null hypothesis could be true, but the null hypothesis is actually false, we have a type 2 error. In general, type 1 errors are considered the more serious of the two. A very good analogy for type 1, type 2 errors is comparing it to a criminal trial. In the U.S. judicial system, the defendant is innocent until proven guilty. Thus, the defendant is presumed to be innocent. The null hypothesis is that the defendant is innocent. So H sub O, the defendant, is innocent. If the defendant is not innocent, then the defendant is guilty. The alternative hypothesis is that the defendant is guilty. So H sub 1, the defendant is guilty. Summary. H sub O, the defendant is innocent. H sub 1, the defendant is guilty. Our possible conclusions. We reject the null hypothesis. We go with the alternative. So H sub 1, the defendant is guilty, and we vote guilty. We do not reject the null hypothesis. We go with the null hypothesis. So H sub O, the defendant is innocent. We vote not guilty, which is not the same as voting innocent. Remember, not guilty means there's not enough evidence to prove guilt. A type 1 error is to reject the null hypothesis. The null hypothesis was actually true. We vote guilty for an innocent defendant. We send an innocent man to jail. Type 2, do not reject the null hypothesis. The alternative hypothesis was actually true. We vote not guilty for a guilty defendant. We let a guilty man go free. Which error do we try to control? Type 1, sending an innocent person to jail. The evidence was beyond reasonable doubt. We must be pretty sure, very bad. We want to minimize this type of error. We need to keep an eye on that. Type 2, letting a guilty person go. The evidence wasn't beyond a reasonable doubt. We just weren't sure enough. If this happened, well, it's not as bad as a type 1 error. And lastly, stating the conclusions to the hypothesis test. Now I have a little cheat sheet for you that I will post, but I don't have that ready to post for you yet. So hang tight. When we get to that part of the homework, I'll definitely have that ready for you. Okay, innocent versus guilty, or not guilty. This is important. Innocent is not the same as not guilty. Innocent, the person did not commit the crime. Not guilty, there's not enough evidence to convict that. The reality is unclear. To not reject the null hypothesis doesn't mean that the null hypothesis is true, just that there isn't enough evidence to reject it. And again, we have the summary, which